So today what we're going to get into is still more of 2.2, but instead of talking about the vertex form, we're going to talk about standard form. So standard form is just another way to look at a quadratic. And what standard form is it's f of x equals ax squared plus b times x plus c. So sometimes they'll give it to you in vertex form, which vertex form, if you recall, is vertex form, which is f of x equals a x minus h squared plus k. So basically what we're going to do is we're going to go from this form and put it into this form. Or sometimes they might actually just give you this form. But I'm going to actually walk you through it, how both of these go hand in hand. So we're going to take standard form, actually not standard form, check that, vertex form. We're going to take vertex form and go into standard form. Now, if you look at this form that we have, all we have to do is expand this value right here. And what expand means is it's basically you can use the box method to do so. So I'll show you that. Draw a box. And what you'll do is put x minus h up top, x minus h down here. So now you do x times x, which is x squared. And then you want to go ahead and do x times negative h. So it becomes negative hx, and then negative h right here times negative h right here. And you will get h squared. Now all you have to do is combine your like terms. So if you notice, x squared does not have a like term, so you just write x squared. Then you notice that negative hx and negative hx are like terms. So all you have to do is put those together, which would be negative 2hx. And then you're left over with h squared, so you just add that on the back. Alright, so you're going to remember that because I'm going to delete it, so make sure you copy that down. So now you see I basically just rewrote the expanded x minus h squared right here. So what I'm going to do now is I'm basically going to distribute that a. So I distributed the a, and if you notice, I always try to keep my variables in order, in alphabetical order. So if it goes a, h, x, and then a, h, just when you write the terms, you always want to keep them in order. So what I'm going to do now is I'm going to break this up to actually show you how this relates to the standard form that I previously showed you. So basically what I did is I rewrote this in a way that you can kind of break it down. So you have the a value, and then you have the b value is right here, and then you have the c value right here. So if I rewrote that, so hopefully you can see what I'm doing, f of x equals a x squared plus the b times x plus c. So if you notice, we have it in standard form. I went from the form up here, which is the vertex form, and I basically just expanded it all the way down. So this would be the version if you actually had some values in there, but I don't know what the values are. I'm just using these for placeholders. I'm using these variables. Now this a will stand for something, this b will stand for something, and this c will stand for something. So if you notice, a stands for a, and it's the same thing as vertex form. We know the a value does what? It can reflect, or it can shrink, or stretch. Now if we look at the b value, what does the b value equal? The b value is the same thing as saying negative 2ah. Now what's super important about this, if we took this right here, this guy, I can find my h value. So what you can do is you can go ahead and take this value and you can solve it for h. So if I solved it for h, well, what would that become? It would be h would equal negative b over 2a. So basically what that is your axis of symmetry. So you can just say that x equals negative b over 2a. So if you're looking for your axis of symmetry, it's basically this equation right here. So this is super important because if it's in standard form, you can just take the b value and you have your pretty much your axis of symmetry. And now you have your c value. So your c value equals ah squared plus k. And well, what does that do? Now, if you look at this, so if you're looking at it, if you can think about this, this is really the same thing as saying x minus h squared plus k. Now, what would happen if you had the x value become a 0? Wouldn't these two things be the exact same thing? Right? It would be ah squared plus k. Well, what happens when your x value is 0? Think of that. Think about last year when you graphed. What was your x value? When your x value is 0, what does that give you? Well, that gives you your y-intercept. So what this green guy is basically, or it is, so c is your y-intercept. So you need remember these. These are formulas for it. That's a formula. Axis of symmetry formula, and A just is the same exact thing. Now I'll give you an example using numbers, because I know with the letters it can be somewhat confusing, but I just kind of wanted to go through that process. Rewind this a few times and try to really understand where the values come from. Really think about it as you go through it. Don't just rush through it. And now I'll give you an example. Okay, so we have a standard form equation. We have f of x equals 3x squared minus 6x plus 1. So the first step, what you want to do is you want to go ahead and label your coefficients. So I have a equals 3, I have b equals -6, and c equals 1. Because remember, in standard form, this is your a value, this is your b value, and this is your c value. Now you might ask, well, what am I going to do with that? Well, you're going to use your vertex formula. What is your vertex formula? Well, if you can recall, if you rewind back, you'll notice that the vertex is basically negative b over a. So my vertex right off the bat would be -6, 2 times 3. So this would come out to 6 over 6, which would give me x equals 1. So now what we're going to do is we're actually going to go ahead and graph the x equals 1. We're going to graph the line of symmetry. So you can draw a graph that looks something like this. And basically what we're going to do is we're going to go ahead and draw in the axis of symmetry. Try to be straight. Use a straight edge because you guys can. I have the stylus. Alright, so now that you have that, you have the line of symmetry. Now what we want to do is we want to go back and find out what the vertex actually is. Well, if you think about it, we already know what the x value is, right? Because we know that if we have our line of symmetry, that is the exact same thing as the x value of your vertex point. So since you have x equals 1, all you have to do is go ahead and plug that into your x value. And what that will do is this will actually give you the y value of your vertex. So when you go ahead and solve this out, f of 1 will equal -2. So basically, remember, this is the same thing as y, same thing as y. So this is your input is 1, your output is -2. So what we know now is our vertex is -1, 1, -2. So we're going to use this guy. We're going to go ahead and plot that in our graph. So go ahead and plot that in your graph. We'll go ahead and pull that up. Pull the graph up. So now that you have the graph pulled up and you look down to your graph, we want to go ahead and graph that point. That point is very important. So the vertex is 1, -2. So it's at the bottom of my graph here, so hopefully you guys can see it down there. And now what we want to do is we want to go ahead and identify the y-intercept. Well, if you recall back in our notes or in this video, remember the c value is actually the y-intercept. It's not the y-intercept, but it's the y value of the y-intercept. So we know that 0, 1 is our y-intercept. So go ahead and plot that. Now once you have that plotted, so remember back what we did previously, if you notice this point is symmetrical, right? The distance from here to here is going to be the same on the other side. So you want to go ahead and plot the reflection of that point. So it would be right here. So now you have 3 points. But you always want to have 5 points. So what do you think you might do from here? Well, we need to find 2 other points. So what I'm going to do is basically just find 1 point. So if you look at my graph, I'm going to pick an x value that's to the right or to the left of my graph. But honestly, I'm just going to go to the right. I'm going to use 3, and I'm going to plug that in. I'm going to evaluate that and see what that gives me. So when I go ahead and evaluate 3 for the function, you notice that I get my output, and my output is 10. So basically, I have a point now. I have a point 3, 10. But you might say, well, didn't you say we needed 2 points? Yeah, in a way, we do have 2 points. So watch when we graph this. So when we go ahead and graph 310, it's right here. And remember I said we should always have 5 points? Well, we have 4 points right now. But if you think back to what we've been doing, if you look at this, symmetrical, right? So I don't have to do any evaluating or any substitution. All I can do is count over. So when you count over, you'll notice that your other point will be right here. So now you have your parabola. So if you go ahead and connect your dots, I'll use a different color because I probably should have used a different color for my line of symmetry, but when you do this, it'll go like this, and you know that it keeps going up and up and up. So put arrows because it continues to go on and on forever. And that's basically how you do it. This is just a different way of graphing when it's in quadratic, when a quadratic is in standard form. So look through this video. If you have any questions, make sure you do your HOT question or your example question if you got it. If you have any confusion, then come up with a confusion question. All right, I'll see you tomorrow or the next day, and good luck.